All set? All right. So as Roger already mentioned, make sure all the students log into the chat with the names of your school. I think everyone's doing that pretty well, so thank you. We are today talking about sustainability. Presenting today is the East Tech team. My name is Luke Kraft from DS Architecture, registered architect. We have Fred Hussein with us from THP, Structural Engineering. We have Bill O'Hare with us from, sorry, just lost my train of thought, Bill.
Sorry, with Panzica Construction.
Sorry, yes, sorry about that. And then Abad Haider from Algebra AEC for representing mechanical, electrical, and plumbing engineering. So our approach to the topic today was multidisciplinary. We're trying to give you a basis of sustainability from different angles. And while this is called a presentation, so to speak, I'd like to have more of a discussion, so feel free to ask questions along the way. Since I am sharing a screen, sometimes I don't see the hands pop up if there's a question, so go ahead and just speak up, or if someone sees a hand raised, go ahead and interrupt me. But I would like to start out with kind of a question towards the students, in that, what does the term, the word sustainability or green design mean to you? Have you heard that term, and what does it mean to you? Excuse me. Any takers? I'll offer up a $5 Subway gift card too for anybody who's interested in throwing out there with what they heard or what they think sustainability means. So I think we're gonna have a quiet group here in the afternoon as well.
Well, we have one response from Craig Watkins.
All right.
Sustainability is how stable something is.
Okay.
Zaire says being able to support itself.
Okay.
Abigail Mondragon says whether something can support both humans and the environment.
All right.
So yeah, those guys be better. Fatima Coates, better the environment.
Okay. All right. So those are some good headway into it. So sustainable triad is kind of the 3-point we're going to make today. It involves 3 different aspects, but in general, sustainability is an orientation design that seeks to reduce the negative impacts on the environment, health and comfort of the building occupants. So obviously, we want to improve the building performance. In general, it's a holistic approach. So a lot of you mentioned it's stable, it can support itself. So that's kind of the holistic approach. But as we go through today's discussion, you'll notice that there might be some trade-offs that has to happen. So sustainable design, there's pros and cons to each different approach. So we're going to kind of touch base on that a little bit. Next slide. Try to make sure it fits the screen well. So a couple of points that were made that really fit into this diagram well is that the 3 points of sustainability, and we're going to start with the financial sustainability. So when we look at a project specifically, the immediate need of finances of the owner. What can the owner afford? How big of a house can I afford? The maintenance, can I afford the ongoing maintenance cost of the building or of the home? So that's the overall financial sustainability. Can be maintained throughout the life of the building. Obviously, very critical part to the process. The next point is social sustainability. And that's how the project or building fits into the community. Does it respect the community? Does it enhance it? Does it unite the community? Obviously, in today's world, we have quite a bit of unity issues. And as architects and designers and engineers and contractors, we can really promote unity through our spaces that we design in the public arena. And then thirdly, we have environmental sustainability. And that's the one we're going to focus on more today. And that's how our buildings affect the climate, affect the environment through their energy efficiency, through the materials, through their engineering. So that's very very important, obviously, and it's directly related to what we do as architects, engineers, and contractors on a day-to-day basis. Now, out of those 3 points, they all start to overlap each other. And in the middle, you see the word sustainable. So when you get a blend of all 3 items, the financial, the social, and the environmental, you reach a pretty good balance of sustainability. And to get there, it really, you need to work with the whole team and the owner to see what kind of avenue, what are the 3 legs of sustainability are most important. But again, we're generally seeking this middle ground of sustainability where it's a balance of all 3 items. But like I mentioned, sticking with mainly environmental sustainability, our buildings consume more energy than any other economic sector. So that's something to really kind of stop and think about. What we do every day, design and build buildings, that the impact that has on the environment is quite profound. And you think of all the road systems that are out there, and that our buildings even outweigh that in some of the damage they can do and energy they consume. So if you look at material production, material installation, and building operation, kind of the life cycle cost of any material is very intensive. And this next slide kind of illustrates that, in that it's a circular motion, and that we start up top here with the resources. And if we're starting with natural resources, you're mining stuff out of the ground, you're cutting down trees, and then it goes to some sort of processing, whether it be a factory, at a plant, that it gets processed. The manufacturer will take that processed product and turn it into a product that can be used out in the market. Then it goes through lots of transportation through distribution system, and then finally ends up at the job site where a contractor is installing it, and then the owner's got to maintain it. And then it's at the end of its life. So one of the things that we look at for sustainability is how long is that end of life? Is that product good for 5 years, good for 10 years, for 20 years? Obviously, the longer the life, the more sustainable that product is, and what happens to that product at the end of its life. Can it be recycled, either upcycled into something better, or downcycled into something that's a little bit less than its prior use? So looking at the whole life cycle is important in terms of not only products, but processes as well, because there's something that's called embodied energy. And as we go through the cycle here, it takes energy to do all those steps. So in the morning, I kind of gave the illustration, in your house, you might have a 2x4 in your wall that helps hold the wall up. But there's a lot of, of energy that went into making that one 2x4. So what looks like just a piece of wood in the house is actually, there's a lot of effort and energy behind that piece of wood. So understanding that helps kind of guide some of the sustainability discussions. Continuing on with the environmental sustainability, the buildings we design can lower CO2 emissions, so we can help offset global warming. We can attempt to save up to 25% or more of energy consumed. We can reduce water consumption and divert waste from going to our landfills. And these documents are taken from a program called Architecture 2030, which is an initiative to be carbon neutral by the year 2030. And so what that means is you're not producing offsetting carbons into the atmosphere. It's a big goal, one that I think we're probably at 2020, we're a little far behind where we should be to hit 2030. But there's a lot of architectural engineering firms that have committed to that and are working towards that. And then in terms of people's health in a building, so a sustainable design also promotes healthy building occupants. So there's been many case studies done that, for instance, in an office building, a sustainable building helps produce more productive employees, produces happier employees. It decreases sick days, which of course goes into increased productivity. And then at stores, there's been case studies when there's sustainable attributes like natural daylighting, better ventilation, that store spending is up. And then finally, if you look at schools, there's been case studies that say, absenteeism goes down and test scores go up when you have a sustainable building that's geared toward the health and well-being of the occupant. So another very key factor to consider when you start your ACE project. So how do we measure sustainability? Because it's somewhat, I don't want to say vague, but there's a lot of things that we could be looked at in terms of sustainability and how it's measured. So what we have on screen here is 5 different systems that kind of measure and score your building in terms of sustainability. And there are absolute tons of them. There's dozens and dozens of them. But these 5 are kind of some of the top ones in our area, with the LEED in the middle being probably the most popular in the area. And that's a system that's been around since about the late 90s. And like I said, it's just a very popular with the state and with private developers. And so we're going to spend a little bit of time on that system just to understand it and how that relates to sustainability. So LEED, like I mentioned, it started in the late 90s, and it's a system that's broken down into categories that focus on energy and atmosphere, materials and resources, the indoor environmental quality. That kind of goes back to the health of the occupant for ventilation and daylight and natural views. Sustainable sites. Is the site an open green field, farmland, or are we taking a site that might be in a downtown urban area that was an old gas station and it's got polluted dirt, and the project will really clean it up. So that factors into kind of your overall points and your measure of sustainability for that project. Innovation credits. So that really allows the design team to be creative in finding new ways for their building to be sustainable. So those aren't prescribed. There's not a list of things you can check off, but there's just different ideas that each design team comes to the table with for each project. And then relatively new for LEED is the regional priority. So obviously different regions of the country and of the world have different issues. Some parts of the world, they might have a big water issue, a shortage of water. So they're going to focus a lot of attention onto that. Luckily in Northeast Ohio, we don't have that issue. But obviously, so the system recognizes that different regions have different priorities. And so they want to emphasize maximizing the sustainability effort in those categories. Location and transportation is another category, and that really kind of encourages buildings to be in populated areas to take advantage of mass transportation and having amenities around you, so you're not using your individual automobile to drive somewhere. A little more on LEED. Each version of LEED gets more and more intense. So we're on version 4.1 right now. And as you can see in this chart here, this was the very early version of LEED. And LEED is broken up into 4 different levels: certified, silver, gold, and platinum. And those levels kind of determine how sustainable your building is. So certified is kind of your baseline. You're a little bit better than most of the buildings in your area, all the way up to platinum, which is very hard to obtain. There's a lot of effort and design and typically money that goes into that to achieve that status. And then as these 4 bars kind of keep going up in time, it's because they get more and more stringent. And why that is because the way we design and the products that are available to us are keeping pace and actually improving, so that in order to hit certified now, it would have been kind of equivalent to a gold back in the late 90s, early 2000s. So we're kind of always upping the bar of how we obtain sustainability and a green design in a building. And it also affects our local codes. So about every three years or so, we adopt a new building code, and it's based on the International Building Code. And so as sustainable design and products and processes improve, they adopt those into the code. So what would have been a really cool feature that would have been silver related back in 1998 is now just basic code that you have to do. So again, we're always building up to a better and better level, and it's getting more and more difficult. But it's the challenge that makes what we do very interesting. Excuse me again. So from a local area, Cleveland does pretty well with their level of LEED buildings. There are other buildings in the area that use other rating systems, but if we want to stick with the LEED versions, there are over 273 registered and or certified projects in the Cleveland area. So registered means you've signed up for the system and you're kind of going after the credits and trying to go after being certified. And certified is whether you actually pass all your credits and the governing body said, yes, you've met these requirements and you are now LEED certified. That equals over 21 million square feet of certified space. So again, I think Cleveland's doing pretty well. And in the Cleveland area, we've got 12 buildings that are certified in the certified arena. 49% are silver, 36% are gold, and 1% are platinum. Again, the platinum is very challenging to get to. Certified, that number is easiest to get to. It's kind of low because silver is actually pretty obtainable with a pretty basic good design for sustainability in mind. For instance, a lot of the state projects, whether it's a new K through 12 school or a new building at a university, if it's state funded, they usually require a minimum of LEED silver. So they've kind of set the bar of, hey, we recognize how important sustainability is. A couple examples, Cleveland State University's new College of Engineering, I can get my cursor over here, is LEED Gold. UH Rainbow Center for Women, Health, and Children is LEED Platinum, which is very impressive. And then Cleveland's Children's Museum of Cleveland is also Platinum. But what's interesting about these three and why I chose the Children's Museum to show is that it looks quite a bit different than the other two. The other two obviously a bit more modern. The Children's Museum was an existing building that they rehabilitated. So, a sustainable building doesn't have to look a specific way. Sustainability goals. All right, so each project will start out with kind of setting what your sustainability goals are. And sticking with the idea of using LEED kind of as a guideline, LEED goals are reverse the contribution to global climate change, enhance the individual human health and well-being, protect and restore water resources, protect and enhance biodiversity and ecosystem services, promote sustainable and regenerative materials, building a greener economy. And so the greener economy is kind of a newer goal. Obviously, if we can support the economy through sustainable design, it just helps everyone involved and just makes it that much more attractive to building owners. And then one of the newer ones for LEED is the enhancement of social equity, environmental justice, community health, and the quality of life. So that's become a very key feature that that kind of goes back to one of the triads of sustainability, of the social, and that how does our buildings that we design influence unity in our environment and provide a more uniform area for everyone to enjoy services of a building. So that's going to become more and more popular in the sustainable design. So it's not just about being energy efficient. So another break for some questions and answers. And I know you have not been received your ACE project yet, but from what you guys know of sustainable design or from the word you've heard, what could some of your goals be for your project? Any ideas, any thoughts?
Okay. Hold on a second. Oh, come on. Here we go. Come on, people. What is the project?
Yeah, so I mean that's a very good point. Like, how do I know my goals are if there's no project yet? So I don't want to speak for Roger, but I don't think a project has been selected yet. So the question is more in general. So it's kind of get the idea of what's an issue to you. And so when we start every project, we sit with the owner and say, what are your key sustainable issues? Is it saving energy, or no, we really care about resources, and we want to recycle, and we want to use renewable resources. Or so in the broad scheme of sustainability, usually there's one passion that really helps guide how we design the building.
Right. So Patrick said that it's a sustainable building. Hold on a second, I just lost chat.
Abigail says preserving biodiversity. That's great.
Create a sustainable building. Fatima, the project will be a building of some kind.
Okay.
We just don't know what it's going to be yet or how we're going to get there.
Yet to come. This is a interesting year,
Yeah.
and sustainability can play a role in that too. In this kind of topsy-turvy year we're having. But, so we can come back to this question. So go ahead and think about it as we continue. So, from my understanding, you guys have had quite a few presentations on, what does an architect do, what does an engineer do, and a lot of those presentations kind of lead into sustainability as well. So sustainability is just one thing that's one of the roles for everyone involved in the design. So the architect specifically will lead and manage the process of sustainability typically, and that's kind of typical for the general building process, whether you're building a new office building or you're doing a new school or even building a new house. Typically, the architect will kind of lead that process and manage it. The same goes for sustainability. Educate stakeholders. So if you're doing a commercial building, say you're doing a school and you've got the community, you've got the owner, you've got the board of directors, it's up to the architect as a lead, but even the engineers as well, to educate those folks about the importance of sustainability and why the project should include those attributes. And then coordinating all disciplines. So there's a huge variety of effort and knowledge that goes into a building. And we're going to speak to quite a few of them today, from mechanical and electrical engineering, structural engineering. So the architect needs to kind of coordinate all those in terms of the whole building and in terms of sustainability to make sure everything flows and fits together and works together correctly. And then administer the rating system. So if the building moves forward with selecting a rating system such as LEED, and they actually want to go through that certification process, typically the architect will administer that and stay on top of all the requirements of that. On the right of the screen is a checklist from LEED version 4, and it's broken down into the different categories that we briefly mentioned earlier. And so the architect will kind of keep track of how many points they're getting in what categories. If it's in the yes column, we feel pretty good about that, getting that credit. If it's in the question mark, we know we really got to focus our design to get that. And if it's a no column because of either it's too expensive or it's just not attainable for our building because of site or whatever required may be, we won't worry so much about those, but we'll really want to focus on the ones in the yellow column. So those are the maybes. Those are where we could focus our design to make sure we hit that. So the architect will kind of maintain and look over that checklist as we go through the process. So in general, architects' roles continue as site selection and building orientation. Not too often are we blessed with the opportunity to help the owner select a site, but sometimes we are. Most times the owner already has the piece of property in hand. But if he doesn't or she doesn't, then we can obviously assist in looking at different sites to see which one is best from a sustainability perspective. Once that site is selected, we've got building orientation. So that's a very key fundamental issue, is how is the building proportion and how is it situated on the site, especially as it relates to north, south, east, and west. The diagram on the upper right shows the building in northern climates here, which we live, and typically we try to orient buildings, if we can, if the site allows, in east and west direction so that we can take advantage of the low summer sun on the south. So this dashed line is the summer sun in the south, and it allows us to capture that heat that can go through the windows. So the image on the bottom right here,
the winter sun.
Excuse me, yeah, winter sun. So the image on the south here, or in the bottom, this is a south-facing elevation. In the wintertime, we would collect lots of heat from the sun, and so we kind of get free heat, so to speak. But in the summertime, that sun is up high, so it's not quite as angled, quite glaring right into the building. And then we can incorporate things like sunshades, which we see in this image as well, to help block some of that summer sun, because obviously that's going to heat our building, so we don't want that. So building orientation is very important, and it's great to work with your engineer on that as well to help situate that. And then another easy aspect is just simple design, limiting your surface area and right sizing the building. which means, if I'm building a house and I think I need 2,000 square feet for my family, but I had the opportunity to build a 4,000 square feet house, just because, the lot sizes can accommodate that, that doesn't make a whole lot of sense, because now I got to pay twice as much, and now I got to operate and heat and cool twice as much building. So right sizing the building allows you to right size all the mechanical equipment and electrical equipment for a more cost-effective project and a more sustainable project, because you're not using energy that you really don't need. And then another key feature is a high-performing envelope. So when we say envelope, we mean the skin of the building, the walls and the roof of the building. And making sure that is high-performing means we've got lots of good insulation. So you see in this picture in the bottom left, you see a person using spray foam insulation. There are many different types of insulation, whether it be spray foam, whether it be the fiberglass bat stuff, or there's the pink board you might see in Home Depot. There's even insulation that's made out of old denim jeans that's been recycled. So there's lots of different insulation possibilities, but making sure your building meets a certain level of insulation will help conserve energy. And good windows and doors. I made the comment in the morning session, because it was still pretty cold outside, that my windows at my house here are condensed up and they've got water on them because they're not the greatest windows. It's cold outside, it's warm inside. And so they're not the greatest windows. So then when they meet, they start to condense. So improving that glass and that window quality will help prevent energy from escaping throughout your window. And same goes with doors. And then joint sealed, that's just kind of like, you can go around your house and see if there's cracks anywhere, or where the windows and doors meet the siding, make sure those all sealed up so cold and hot air doesn't get in when you don't want it to. That all goes into high performing envelope. And then material resources, one of the other key items that the architects really focused on. And the picture to the top right is a very simple picture. It's a renovation of an old building. And why is that sustainable? Is because we're using a lot of this building, the brick and all the floor structure and all the stairs that within there, we can reuse all that. So we talked earlier about embodied energy. How much energy went into making that brick, and it would be kind of a shame just to tear it down and throw it into a landfill when this building, regardless of whether you think it's beautiful or not, has so much potential to be something new and fit a current need. So reusing buildings that we have in general is a very, very sustainable avenue to take. And then recycling construction waste. So when you demolish and build a new building, or even when you're building a brand new building from scratch, there's going to be waste. To make sure we divert that and recycle as much as possible. And renewable materials. So there's materials that can be made out of bamboo, made out of old denim, made out of straw and wheat products. So there's products that can be used as a renewable material, so that when you cut it down, it grows back extremely quickly, so you're not depleting the earth of its natural resources. And then low VOC materials. I don't know if anybody's heard of the term VOC. That stands for volatile organic compound. So if you ever get into a new car, or if you get new carpet in your house, or even new paint on your walls in your house, and you smell that smell, it's like, oh, new carpet smells great, or this new car smells wonderful. That's actually bad chemicals that are off-gassing. So you want that smell actually to go away as soon as possible. That means they're not harming you anymore. So we actually go to great lengths when we design buildings to remove those or reduce those as much as possible for occupant well-being in the end. And then finally, products with recycled content. That's another really big feature that we can deal with now, and most of the manufacturers are really up to speed on this, where if you order steel for your frame, it can be recycled content, or your drywall can have recycled content, your ceiling tiles. Most things that we get nowadays can have a certain level of recycled content if you make sure you specify and ask for it. It used to be more expensive because it would be kind of labor intensive to kind of break it down and put it into the new product, but it's getting more and more cost neutral as we go along. And then switching gears to the owner's role, that's kind of where sustainability starts. Sometimes the design team needs to educate the owner on why it's important, But when you have an owner on board that knows and understands the importance and is committed to the importance of sustainable design, it makes the project a whole lot easier. We're very fortunate here. We got a couple of pictures of Metro Health's, some of their leaders and their commitments. They're very committed to sustainable design. We're very fortunate in Northeast Ohio to have major institutions like Metro Health, the clinic, Case Western, Sherwin-Williams, Cleveland State, that really have a focus and commitment to sustainability. And when that happens, it really becomes the driving factor for successful sustainable building. And they understand the short term. It's obviously good when you're designing the building, but it's also very good in the long term, and that it saves energy and the building occupant health and the benefits they get from that. So when they understand the benefits of it from the very get-go, it's a very good beginning to the process of building design. All right, so I've rambled on enough. I'm going to hand it over to Fred, who's going to talk about civil and structural engineer and their roles in the process of sustainability.
So just real quick to remind you guys what a civil engineer does. The civil engineers, they design a lot of the aspects of the project site or the land around the building. They design the site structures that allow for movement of people and things through the site, parking lots, drainage ditches, things like that. The underground utilities on the site, like the sewer, the gas line, the electric line. They determine the existing site grading and lay out the new site grading, and that's the slopes, the hills of the site, if it's flat or if it's sloped or if it's hilly. They also design the site utilities such as the parking lot lights, emergency call boxes, things like that. And they help to develop the SWPP, which is called the Stormwater Pollution Prevention Plan, that helps control pollution during construction. Could go the next slide, Luke.
Absolutely.
So on the right, we've got an example of a project that has quite a few sustainability features worked in by the civil engineers, and that's Public Square in downtown Cleveland. If you guys haven't been there to see it yet, I highly recommend it. It's an amazing space area to just have for the public. And so some of the ways that the civil engineers use what they design to make the site more sustainable would be to control stormwater runoff, which helps control pollution. So that they'll use some retention basins or structures. They'll use pervious pavements, which there's quite a bit of that in Public Square. It looks kind of like it's concrete that looks kind of like a Rice Krispie treat. They leave out some sand and water can drain through it to the groundwater, which allows filtration of pollutants out of the water naturally before it makes its way into the lake. And then also stormwater filtration systems. Sometimes they'll collect the water and actually filter it before dumping it into the sewers. Civil engineers will also integrate sustainable technologies into the site. So one example is if you go to UH main campus, I think Metro has some of them too in Cleveland Clinic, in their parking garages, you'll notice electric car charging stations in some of their parking lots and parking garages to help promote the use of electric cars. They'll also specify low energy usage site utilities, some of which will be solar powered, some of which are LED, things like that to try to limit the amount of energy used. And they'll design in some reclaimed water systems, such as rain barrels, ways to collect the water and reuse it. So then you're limiting the runoff and limiting the use of new water for things like watering the grass or flowers or sometimes even flushing the toilets. Civil engineers will use recycled materials. They'll specify the use of recycled materials on a lot of their things. One example of that is pavements and bases. There's machines when they redo streets that'll actually chew up the existing asphalt, melt it back down, and make new asphalt out of it. You can do that with concrete too. Site utility items can use recycled materials as well, similar to what Luke mentioned with the buildings, with recycled steel, aluminum, things like that. And then they'll also a lot of times try to specify the use of local materials, because a lot of the carbon emitted from the construction aspect has to do with actually getting materials to the site. Saw a presentation earlier today, and they were talking about aspects of the building that actually came from as far away as Australia. And we do have a lot of things from China, and that's quite a bit of carbon to transport those things there. If you could go to the next slide, please, Luke. This is my favorite slide because it explains what I do every day. I'm a structural engineer. So structural engineers design the systems that keep the building standing. I usually give the example that architects design the skin, structural engineers design the skeleton. And our friends Abad and Sharik, they design the heart and the blood vessels and the lungs. So to compare it to a human being. And the structural systems that hold the building standing are the roof framing, the floor framing, there's columns, posts, there's walls, not always load-bearing walls. Sometimes they're shear walls, lateral walls, things that keep the building standing after we have a big windstorm like we had last week. If you could go to the next slide, please, Luke. So remembering what a structural engineer does and relating it to sustainability, one thing we can do which helps with financial and environmental sustainability is optimizing the systems, the structural systems we design to use less materials. That's always the goal of a structural engineer, sustainable or not. Can also use sustainable materials. Examples of that are wood and bamboo. And wood, if you guys shop at the West Side Market and you look across the street, or if you read about it, there's a new pretty large building made out of wood being constructed there. Right now, I think all you'll see are the concrete shear walls and things like that. But the use of wood is becoming more and more popular in the industry. And then there's some pretty interesting experimental materials out there. One of our teammates that helped us put this presentation together is Chris with Red House Studios. I encourage our students to look up Red House Studios and some of the research they're doing. They're using the roots from mushrooms and compressing them and making boards out of them to make houses. So you can harvest the mushrooms and put them on your pizza or cheeseburger or whatever you like, and then you can compress the roots and build your house. It's incredibly interesting. And then we'll specify recycled materials. The one that always comes to mind is steel, but there's also a couple of things we can use to help replace some of the cement and the concrete, which are fly ash, which is an industrial byproduct from making cement. And then there's also steel slag, which is an industrial byproduct from making steel. And we can use those to replace some of the cement to try to reduce the carbon footprint of the building. And then the last thing, and this is becoming more and more prevalent in the industry, at least between me and my architectural friends, we'll go around the building and we'll try to mitigate thermal breaks together. Thermal breaks are areas where systems go from the inside of the building to the outside. So that detail on the right shows some steel that goes through the building envelope or skin to the exterior. That picture on top is it in real life after it was constructed. And what that does is it'll try to pull warm or cold air into the building. And that makes it harder for our friend Abad to heat and cool the building and keep it a consistent temperature. So we'll go through and put thermal breaks there, which is like a plastic material or an insulated material to break the system to allow thermal isolation so that conductivity cannot occur. And with that, we'll hand it over to our friends at Algebra AEC to tell you all about the blood vessels and heart and all that interesting stuff.
Yeah, so the mechanical engineer, in terms of sustainability, they're just trying to balance two things, I guess, sustainability wise. One is the human comfort and health of the occupants, and the other is, of course, the energy. And it's those two things that that are the key elements sustainability wise. The other, of course, being the economic sustainability. The first thing that a mechanical engineer would do is to look at the climate of the site and the building. Obviously, if you're building something in Ohio, in Cleveland, you're going to approach your design differently from if you were building in Hawaii or in the desert or wherever you would want to go. So right here we have a yearly analysis of the wind and other environmental and climatic data from in different directions So this is like compass rose for different data points: wind speed, temperature, rain or humidity, in sort of different directions for a typical site in Mayfield, Ohio. If you could advance the slide, please. And once you have that climatic data, you're going to want to you want to do some studies to see what sort of measures you can use in that climate. So here's two different types of measures you can use. One is called, they're both types of economizers. Economizers are ways to, it's a way to use the outside air, which might be cool enough or warm enough, and to supplement the air that you supply to your building. So this is, some of it is actual data, and sometimes you use simulations to generate these plots. But it basically lets you see which parts of the year you have temperatures that are low enough outside that you can use the air outside to actually supplement your cooling. So for example, the left plot shows from January to December, from left to right on the horizontal axis, and the vertical axis is temperature. And you can see some of the year that's been colored blue, you have cool enough outdoor air that you can actually economize the supply air for your mechanical system. Luke, could you please advance? And then the I guess the bulk of the mechanical design, the role of the mechanical engineer, is to design the HVAC system. HVAC is heating, ventilation, and air conditioning, cooling, refrigeration sometimes also thrown in there. And what does that mean? It means making the, as Fred said, the sort of circulatory system of the building, where you want to circulate new fresh air and take out old air. You want to make ducts to send this air throughout the building. You don't want to make the ducts too big because that takes up waste space, takes up space. But you don't want to make them too small either, because the smaller you make a duct, the harder it is to move air through it. So if you've ever considered, blowing into a straw, it takes a lot of force for your lungs to blow into a straw. It's the same idea with a duct. The smaller the duct is, the harder you have to force air through it, and the higher force that you have to use actually translates to using fans that have, take up more energy, or using supplemental fans sort of in between. So the job of the mechanical engineer in this aspect is to balance those two design features, to make the ducts in a way that gets all the air gets the air to where it needs to be, but also isn't over the top. Can you advance, please? Other sort of measures that you can take in terms of sustainable design is just when you specify different types of equipment to use. For example, in this climate, we often use condensing boilers, which actually, a condensing boiler is a way to, heat a fluid up and move that heat around and use it for, extract that energy from the fluid. A condensing boiler is a little more efficient than a standard boiler in that the waste gas is actually used to preheat the fluid. So you're sort of double dipping into that, into the amount of energy you put in. And so you can get efficiencies up into the 90% for something like that. In the the photo or the diagram below you on the left is a type of system called geothermal, where in the wintertime you actually extract heat energy from the ground, and in the summertime you take heat energy from your building and sink it into the ground, and the ground being a reservoir that when you're deep enough, it's sort of it can take or give a lot of heat energy. It has what's called heat capacity. Another type of thing that you can do in the top right diagram is it's called an airflow analysis. You can optimize where you put fans or ducts or what have you to minimize the number of those that you need. So for example, this is the diagram you see up top is a parking garage with air flowing across it, and you're trying to remove harmful compounds that, when you have carbon monoxide from cars or nitrous compounds that are given off that are pollutants that aren't good for human health. That particular analysis is done for that purpose. Active chilled beams is a way of cooling using fluid. Again, so fluids or liquids have what's called a higher heat capacity than air, and heat capacity just the ability for a substance to store energy, heat energy, and because water and other liquids have a higher heat capacity than air, it's often more efficient to use the treated air or liquid to actually move heat around in the building. If you could go to the next slide, please.
And about just, it's 2:53, just to be cognizant of time.
Sure. So the other thing that in terms of analysis of spaces that the mechanical engineer would do is to see if there's any problem spots. So for example, this is an analysis where you can see in red the outdoor air temperature and in blue the room temperature. And when people open a window, so for example, sort of in the middle of the plot, you can see that the blue kind of tracks along with what the red is doing. And that was a problem where we were getting complaints that the owners of the building were complaining that occupants were feeling cold, but it turns out that people were opening windows and forgetting to close them. So this is one way, doing an analysis to see where these problem spots occur is one way to see that. You could advance, please. The plumbing systems are, I guess, ways to move around water and save the amount of water that you use. So the most obvious method that you might see is a dual flush toilet, where if you flush half the cistern or the full tank, depending on whether you go number 1 or number 2. There's solar hot water, which is a way to, rather than using a boiler or supplementing a boiler with heating water using solar panels, not electric solar panels, but actually pipes with water in them. You can also collect rainwater runoff and use that for supplementary gray water systems. If you could just advance to the next slide, please. The electrical engineer will, in terms of sustainability, probably is designing things to, in terms of lighting and and also lighting and daylighting to make sure that the human occupants are sort of have a comfortable environment and a healthy environment, and try to optimize the amount of sunlight coming in, but not to the point where it's creating too much heat in the space that has to actually be detrimental. So you're playing another balancing game here with the amount of sunlight that enters the building, but you want to use the useful visible light, but you don't want too much heat generated. And you also want to minimize glare. So there's a few different analyses here. One on the left is just the amount of daylight entering. The couple in the middle and on the right are about glare and minimizing glare, or hot spots where glare could form. If you could advance. Other things that electrical engineer would do is electrical solar panels, which are photovoltaic solar cells, in conjunction with the typical grid power, or maybe not, maybe in place of. In addition, you can use wind power. So those are the two at the top. Also, you want to plan out and do an analysis to see whether you can decrease the number of, so for example, in the bottom right, you see a space, a plaza space. This is actually the Tri-C Metro Campus Plaza, part of it. And the analysis here was to minimize the number of light poles that are on the space, but achieve a sort of, a blanket of an adequate light level across the entire space, but not have too many poles, because those light poles are always on, always, well, not always on at night, and just wasting energy if there's too many of them. And I think that's it for MEP.
So we'll kind of bounce over to kind of our last major role in sustainability, and that's the contractor's role. And Bill Panzica will speak to that.
Yep. So as we've kind of said, this is a very designer-led process in terms of this sustainability. Typically, as the contractor, our role falls under two main categories. One is assisting the design team and the owner with the design of the building, and the second is managing the process through and ensuring that those measures are taken into account and are actually realized as we build the building. So during the assisting in the design, our role is typically weighing in on application on lesson learned. So for the many different sustainable products and roles and methods out there, weighing in on what's been successful, what will work in this given applications, giving our opinions on different things like that, as well as helping with how we've seen problems solved in other buildings, just helping apply these things between the different products. The second is with life cycle analysis. So this is, Luca talked about this earlier, but a couple practical examples we typically do is, we've done on a lot of different projects, is helping the owner and the design team evaluate between using a more efficient, which type of HVAC system to use. One we've had a lot of times is trying to use like a PTAC, which is a through wall air conditioner unit, like you would see in a lot of hotels or smaller building, versus using more centralized systems, which are more initially costly than the other way around. So helping him not only evaluate what's the initial cost, what kind of energy savings are you going to get, versus life cycle and maintenance costs on the meantime as that as well. The other one we typically help evaluate a lot is different structural systems. So if you're building a building, you can build it out of concrete, you can build it out of sometimes just out of studs. You can build these things out of mass timber, like some of the other things we've talked about. There's different factors in there. Concrete or a steel building is going to be more expensive, but it's going to have a longer lifespan, and you may be able to charge more, make more in rent, make more in revenue as the owner of that building. And the trade-off in that is it's sometimes a much smaller initial cost on some of the different systems. So helping make those points and make those decisions is a major part of what we do early on in this process. And then as we move into actually building the building, again, it's making sure that the decisions that are made and that the products that are specified are actually used and are used correctly. So we help make sure that the products that are specified are used. We make sure that they show up on site, they're stored correctly, they're used in the way that they're supposed to do. And then as far as the lead and the other programs, we make sure that they're entered into those different systems and tracked accordingly to help meet any of those goals and those certifications. Disposal and recycling of materials. I think we touched on this earlier too, but for an example, a project that we're working on now is a renovation. So we've had demolition on the building going through, and you have a demolition contractor that's swinging heavy equipment all over the place, is destroying things left and right. But at the same time, they're also going through and they're sorting out piles into the back. They're setting the steel all aside. They're setting the concrete in one place. And then everything else that they're bringing out, they're making sure is going to a waste handler that's able to sort those materials and divert anything from a landfill possible. So we have between 50% to, I think on some of the upper lead level things are 90% plus that you look to recycle material in buildings. So that's another process that we manage. And then here towards the end, I just listed a couple other general items we do, like with the SWIP plan, making sure that stormwater on site is managed, making sure that any lead or any other certifications are taken care of. And then as far as listed safety practices and policy, making sure that any temporary things are in the way and are used in a responsible way. We're not sending temporary heat more so than we need during the building process. We're not clearing out or losing any material by not storing it or protecting anything properly as we're building. So I think those are the main points, and turn it back over to Luke to close it out.
All right, thanks, Bill. And so we are right at actually a little after 3. So this is kind of good timing to kind of wrap things up. We can take some questions here at the end. Apologize for not leaving more time for questions, but in terms of some activity and some homework, I don't know how long you guys get for the homework, but one of the things we want to take a look at it is, examine your house. What are some of the sustainable attributes you see in your house? Maybe someone just got new windows. And then also look what can be improved. As an example, I look at my house and I know my walls are not insulated. So I have a hard time saying that as an architect who promotes sustainable design, that I live in a house with uninsulated walls, but it's a 60-year-old house, and which is one thing I've not gotten to yet. So there can be a whole list of things that can be improved in terms of sustainability. And then the other option could be to visit one of the local LEED buildings. And if you just go Google Cleveland LEED buildings, a bunch will come up. We listed several earlier. Just kind of walk to those buildings. A lot of them are public, and just see what sticks out to you was sustainability, maybe or a sustainable attribute. Maybe you'll see the Rice Krispie concrete that Fred mentioned, or maybe you'll see the sunshades that was shown on some of the other slides. So just look for some of those items that you think are sustainable and kind of jot those down and send those in. So with that, I'll kind of open up to any questions. I know we are after 3 and people have meetings and classes to get back to, but be happy to answer any questions if there are any.